This tutorial is going to show how to use the Harmonized Data Access, also called in this tutorial HDA, one of the services of the Destination Earth Data Lake. The HDA is a tool to discover and access data provided by the Destination Earth Data Lake. It already provides access to around 170 collections including DestinE Digital Twin data, and the number keeps growing. All of this is possible using a single set of credentials. This set of credentials allows you to explore these 170 distributed datasets via a mechanism called data federation. All these datasets are provided via a unique interface, based on the STAC specification, so you don't have to know the access method of each data provider. Even if you are not a registered user, it is possible to discover collections and see what is offered by Destination Earth Data Lake. To explore the HDA and the DestinE data portfolio, start by navigating through the Destination Earth Service platform. Go to the Services section and look for Access DestinE Data on the edge. From there, select a Harmonized Data Access and click Go to Service. You will be redirected to the DestinE Data Lake portal, specifically to the DestinE Data Portfolio page. Here, you'll find a wide variety of datasets to discover, including digital twin data, land cover, satellite imagery, statistical data, and much more. You can discover collections both through the web interface and the REST API. Okay, so what if you want to download specific data? In that case, you need to be a registered user first. To start your journey with Destination Earth, you'll need to register on the DestinE platform. Here's how. Visit the DestinE platform website. In the upper right corner, you'll see that Sign In button. Click on it. Then, select to register, and follow the steps to create your account. You'll provide details like your username, password, and so on. Please note that you have to request an upgraded access through DestinE platform to access new DestinE Digital Twin data. To apply for upgraded access once you have successfully registered, log into your DESP account. Navigate to Access Policy Update. Choose the type of user you are. For example, if you're a researcher, select Academia and Research. Click on Apply here. Fill out the form, and your request is submitted. Alright, now let's get back to the Harmonized Data Access service of DestinE Data Lake. You can access HDA in several ways. Via the Jupyter Lab environment provided by the DestinE Data Lake STAC service. On a virtual machine offered by the DestinE Data Lake Islet service. Via other DestinE services such as Insula. Or through your own local environment. No matter which option you choose, HDA works the same across all methods since it's provided as a REST API. Let's try working with Jupyter Lab. Digital twin outputs are the flagship datasets of DestinE Data Lake and DestinE. To get started, try finding and downloading data provided by the Climate Digital Twin. Remember, it requires upgraded access previously described. You can locate the appropriate script in the left panel. Navigate to HDA and DestinE Digital Twins. Then, select DT Climate Notebook, whose full name you can see now on the screen. You can already note the notebook name correspond the collection ID of the dataset as described in the DestinE data portfolio. First, log into HDA using your Destination Earth credentials, which you can obtain from the Destination Earth service platform. Next, you'll need to build a query and make a data request. Once the query is complete and the data is successfully found, you can proceed to download the product. You'll be informed if the data is being processed or downloaded. When the download is complete, you'll see a progress bar and a .grib file in the left panel. Now, it's time for visualization. For this, we'll use EarthKit, a Python package designed for working with digital twin outputs. the image has been plotted. Now let's give it a try with the Extreme DT. The notebook dedicated to Extreme Digital Twin, Extreme DT, can be found in the same directory. It's named DT Extremes, or DT Extremes series. Let's work with the second one, that series notebook, to explore a different visualization method compared to the previous example. As before, start by logging into HDA using your Destination Earth credentials, which you can obtain from the Destination Earth service platform. Next, you'll need to build a query. Important, keep in mind that Extreme DT data is only available for the last 15 days from the current date. Be very precise when choosing your date and time. Once you've configured the query, this time, we'll download data on wind gust and mean sea level pressure. Make the data request. Just like in the previous example, the results will be displayed. Now, you can download the requested data. Since this dataset involves a larger volume of data, the download process might take a bit longer. However, you'll still be informed about the status of your order. Once the data is downloaded, you'll see another file appear in the left panel. Take a moment to examine the structure of the data. You'll notice that 2 variables were downloaded for 5 time steps. Finally, let's move on to visualization. 5 images have been successfully generated, just as expected. Everything works perfectly. It was mentioned that a single set of credentials allows you to explore multiple providers and datasets. So, let's try something completely different, like Meteosat MSG data provided by EUMETSAT. You can find the appropriate notebook in the HDA folder under Data. As before, start by logging into HDA. Next, define the query. Inspect response. As you can see, it is indeed MSG product, provided by EUMETSAT. Once the query is complete, download the product. The downloaded product is in a zip format, so you'll need to extract the data. First, let's read the data. Print the available variables, and create an array containing 2 variables. The high-resolution visible HRV band and the infrared channel IR 108. Next, we'll inspect the data attributes and prepare for visualization. You can view a list of all available color composites. We'll select the natural color composite and plot the results. Here it is. Now, let's move on to colorized IR clouds. Once again, the corresponding image has been successfully plotted. How is it possible that various datasets from different providers can be accessed through HDA? This is made possible by the PySTAC protocol and the REST API. In the REST directory, you'll find 3 tutorials on how to use the REST API with HDA. In this video, we'll focus on the Quick Start tutorial to demonstrate the high-level functionalities of HDA. At the very beginning, you'll see some basic endpoints, URLs, used by the HDA REST API. Stack API. Collections. Items. Search. Now, let's try to find collections that provide chlorophyll A concentration and algal pigment data. For this activity, you don't need to be logged in. A list of relevant collections was successfully returned. Next, it's time to search for specific items within a collection. Let's choose one of the Sentinel-3 collections. To proceed, you'll need to log in. Build a query using basics filters like date, time, box, and limit. Also, sort founded products in descending order. Send a request to HDA and download the product. The product was successfully downloaded and is now listed in your directory. Users can access data provided by DEDL via the HDA stack-based API, but also via other tools such as pySTAC and EOdag. Let's start exploring with pySTAC. The pySTAC tutorial can be found in the pySTAC directory. After logging in and setting your credentials as environment variables, you're ready to dive into pySTAC and HDA. First, connect to the API by retrieving the root catalog or landing page of the API using the client.open function. Next, query all available collections along with their short descriptions. Since HDA provides access to datasets from various providers, let's verify which institutions are federated with DEDL. You'll notice a variety of Earth observation entities, including EUMETSAT, ESA, and ECMWF. Now, let's move on to a more detailed search, specifically for Sentinel-1 GRD items. Define your query and send the request. A list of items has been returned. One of the key advantages of Stack is the ability to access assets, in this case, specific bands of the Sentinel-1 product. Let's see which assets are offered for Sentinel-1 GRD items. All the expected assets for Sentinel-1 GRD are available. Since you now have access to assets, you can even visualize a thumbnail directly, without downloading the data. Of course, items can also be downloaded, and once downloaded, they will appear in the left panel. On the other hand, you can explore datasets in a more interactive way using the EOdag tool. In order to access EOdag, you have to be user-granted with an Access to Stack service. Then, you can find EOdag on left panel. To find some products, you must define provider. Let's say EUMETSAT Data Store, EUMETSAT_DS. Product type, try with Metop Data. Then, set time range. And finally draw an area of interest of your search. Click Preview Results. Now, you can see results of your search. You can also click on a Generate Code to create a snippet of code, which could be useful for further work. This tutorial explained how to use the HDA, either by interacting directly with its stack-based API or via tools such as pySTAC and EOdag. We showed how to obtain the list of available collections as well as how to search and access specific data products. Visit Destination Earth Data Lake GitHub page and deep dive into the possibility which are offered by HDA and other DEDL services. Thank you.